Okay, 7th grade, lesson 5.6, scale drawings is what we are going over today. You should be working on your warm-ups. Let's see how y'all did. Okay, so evaluate. What does evaluate mean you're doing? You're solving it. Whatever the steps are, you're solving the problem. So, write your answer as a fraction or mixed number. So you can use a calculator to do all this. Or you can write it on paper. So this is negative 5/4 divided by 1 plus 1/8. So what's 1? You have to do this first. You can't. So you do 1 plus 1/8, which is 1 1/8. So do negative 5/4 divided by 1 1/8. Your answer will be negative, yes?
Yes.
Yes.
Negative 1 and 1/8. That's exactly what I did. But what's up with the plus 4?
I just said. You're going to add the 1 to the 1/8. So negative 5/4 divided by 1 1/8. You should get. And then write it as a fraction or mixed number in simplest form. So you should get negative 1 1/9.
What? How'd you get that? Yeah, I got that one. Yeah, I got that one. How'd you get that?
I did 5/4 negative divided by 1 1/8.
Wait, but the 5 is negative. 5/4 is negative.
I put it negative. That's why the answer is negative 1 1/9. Okay, so now that you know how to do it, do the second one. Okay, so the vocab you should be writing: scale drawing, scale model, scale, and scale factor. These are the things you're going to be learning today. When you hear scale factor, scale drawings, this is all having to do with ratios still, guys. Okay? So it's just a fancier word. So somebody tell me, what is a scale drawing? Joel.
A proportional, two-dimensional drawing of an object.
Very good. It's a proportional, two-dimensional drawing of an object. Okay, so that means it's on paper, you drew it, and it's to scale. If architects draw a building, is it life-size?
No.
No, that would be ginormous. You can't draw a life-size, I mean you can, but I would not recommend it. So they draw a building to a smaller scale or smaller version of what it's actually going to be. And when they say it's proportional, they make the measurements of their drawings so that you could multiply it times like 100 or whatever, and it would be the actual size of the building. Does that make sense? Blueprints, architectural drawings, that's how that works. All right, somebody tell me, what is a scale model? Joaquin.
A proportional dimensional model of an object.
Okay, so now after they've drawn the building, they construct a small model. Did we make any scale models recently?
Yeah.
The tabernacle, very good. Those are all scale models. Now, did you take a measuring stick and make them perfectly proportional to what your Bible said? Probably not perfect, but they are to a scale proportional. Good. All right, the measurements in scale drawings and models are proportional to the measurements of the actual object, meaning there's a fraction of what the actual size of the object is. Make sense so far? So, somebody tells me what scale means. Somebody tells me what scale means. I can't speak today. Sam.
A ratio that compares the measurements
Shh.
of a drawing or a model with actual measurements.
Yes. So it's comparing the drawing measurements to the actual measurements. For instance, right here we have the drawing is 1 inch to the actual size is 10 miles. Okay? So if I had a drawing that was, 5 inches long by 10 inches long, how big is that actual object?
10 miles and 5 miles.
50 miles. Because I said it was 5 by 10, so it'd be 50 miles by 100 miles.
Wow.
Okay? Because it's a ratio. Does that make sense?
Yeah.
Kind of. All right, let's go through it. You sounded like the robot on Brain Pop.
No way.
Was it the robot on Brain Pop?
Yeah.
Ah, I thought you made the noise.
Yeah.
Easily entertained. All right, example 1. what is the actual distance? If I have to tell you all to be quiet again, I'm making you go back to your seats. What is the actual distance, D, between Cadillac and Detroit? So first, let's find Cadillac on the map, right here.
Found it.
And where's Detroit?
Somewhere.
Right there.
Right here, bottom right. Cadillac to Detroit. What is the actual distance between these two? Okay, how would you find the actual distance?
Miles. Measurable miles.
1 centimeter.
Okay, this is your scale factor right here. If I were to take a ruler and measure from Cadillac to Detroit, I would get a certain number of centimeters, right?
Yes.
Then I would take those centimeters and multiply it times 50 to see how many miles it was.
Oh, yes.
All right, so let's look at this. So I'm gonna take a centimeter ruler to find the distance. Okay, and just so you know, your online here, it has a tool, a ruler tool, so you can measure things. It might not have it on the example, but when you go to do the work, there's a tool you can use. Okay, so measuring here, what is the distance? Let me move my face. From Cadillac to Detroit. Look here, we have 1,
3.5.
2, 3.5 centimeters. Very good.
350.
3.5 centimeters. So can I make a proportional ratio?
Yeah.
Yes.
Yep. So I'm going to use my scale 1 to 50 and write a ratio that is 3.5 over, I don't know. Okay, so here's my scale factor, 1 to 50. We measured and it was 3.5, the centimeters, so you keep the centimeters with the centimeters, see them on top?
Yeah.
How do I find D?
Multiply.
Cross, multiply, and divide. Okay, so 3.5 times 50
175.
divided by 1,
101.
it stays the same, 175. So how many miles is it from Cadillac to Detroit?
175.
175 miles.
So fast, Joe.
Any questions?
No.
All right, go do your try-its. Oh, you can also do this table that we all love so much.
Ew.
That's the hard way. Do it the easy way, right here. So a scale can be written without units when the units are the same. So if it's feet to feet, you don't have to label it. Okay? The value of this ratio is called a scale factor. The scale factor describes the multiplicative relationship, say that really fast, between the dimensions of a scale drawing or the scale model and the dimensions of the actual object. Okay, so let's do this example. Example 2, write this in your journals.
Okay.
So, a scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What does 1 inch represent in the model?
10.
So it'll be 10.
10 feet.
What do you say?
Good. So 10 inches to 100 feet. If I were to change the measurements, 1 inch represents 10 feet. So all we did was simplify this. Okay, I compared 10 inches to 100 feet and divided both by 10 to realize that 1 inch represents 10 feet. Comprende?
Yes.
All right, so what is the scale factor of the model? What was the definition?
The scale.
Scale factor is
Scale factor
The
is
value of a
the
scale
value
when the units are the same.
When the units are the same. Are the units the same here? No, but can we make them the same? Yeah, how would we make these the same?
body.
We would change feet to inches, right? So how many inches are in a foot?
10. I mean,
10.
12.
12. So you'd multiply 10 times 12, which would be
20.
1.
10 times
Oh,
12,
120.
120. So the new scale factor would be 1 inch to 120 inches. When it's the same measurement, you don't have to put the label inches. You can just write 1 to 120.
Oh.
All we did was change the scale right here to a scale factor, meaning we made it to where it had the exact same measurements. So when we had 10 feet, We needed to change that to inches. 10 times 12 gives me 120. So that's the new bottom number. Instead of 10 feet, we have 120 inches.
Oh,
Make sense?
oh,
Questions?
oh.
So you can write the scale factor as 1 over 120. All right, go do your next set. All right, 7th grade, this is example 3. Put this in your journals.
Okay.
Okay, the scale drawing of a square computer chip helps you see the individual components of the chip. Find the perimeter and the area of the computer chip in the scale drawing. So this is a picture of a computer chip. This was what they look like, guys. They're a lot smaller. They're about this big.
The M1 chip.
How do you know that?
That's a computer chip. I built computers.
Did?
Can you make
I
me
could
one?
build you one. Give me money.
Okay, how much?
How nice of one do you want? $100 then can get you a computer.
He makes one for $100.
You can give me like $1,200. I'll make you a really nice one.
1,200? Okay.
What else would you
All right, here we go. So we're going to find the perimeter and area using the scale drawing. So we have 1 centimeter to 2 millimeters. Okay, so first thing we need to do what?
It's on.
Oh,
Yo, come on.
Okay.
What did I do?
I know, we have a giant ruler. So we're going to measure how far.
Centimeters. 4.
Good. So we know that the. I know they like to not answer until they know the exact answer. So we measured that the width of this computer chip is 4 centimeters.
yes.
Okay? So we're going to use our scale factor. Oh, we don't even have to do that. You can do. What is the perimeter of this chip?
4.
If it's. No, what's perimeter?
Oh, the outside.
All the outside, right? So if this one is 4, it'd be 4 times 4,
16.
which is 16 centimeters. Okay? How would you convert that to millimeters?
You
Divide that
no, I don't know.
You see how much?
Our scale factor, yes, divide by 2.
8.
No.
They're doing it the long way, but yes.
I did get it right. I told you.
Oh.
Oh, times 2. Because we had it in 16 centimeters, but I want to know the actual length, which is millimeters. So you're multiplying times 2.
There's 2 millimeters in 1 centimeter.
16 and 16 is 32. This is the scale factor. Not. That's not good. You're going to use it in high school. Because you find it when I wiggle it. It makes it huge, too. So you can find your mouse. Okay. So you don't have to write it like they did it, guys. Okay, we used our scale factor, 1 centimeter to 2 millimeters. So we had 1 over 2. Okay, and then you multiplied it times 16 over x, and we solve for x. All right, I'll write it.
Wait, never mind. I know how to do it. 16 times 2.
I know, but you didn't understand what I said, so do I need to write it?
16 divided by 2 is 8.
All right, so 32 millimeters is the actual width of this, or perimeter of this computer chip. It's very little, 32 millimeters.
That's so tiny.
All right, compare the side lengths of the scale drawings with the actual side lengths of the computer chip. Oh, wait, what's area? How do you find the area of this?
4 times it's 16.
Well, it's,
No, that's the perimeter. 16 times 2.
but it's also the area.
Ha! Ha!
So the perimeter would be 4 plus 4 plus 4 plus 4. So that gives you 16. The area is 4 times 4, which is also 16. However, what is the actual area in millimeters? So if it's 16 centimeters, what is it in millimeters? 32. So the perimeter and the area in this case are the same.
Yes.
Oh, wait. We got to change the side length first. My bad.
Oh, it's okay.
So when you are finding measurements of something, like the area of something, you have to convert the side length before you do the multiplication. This is huge. Make sure you remember that. So I can't just convert 16 centimeters to millimeters because you're multiplying to find the area, and so the multiplication would be off. So first convert this. If it was 4 centimeters, how many millimeters is it? 8. So this is 8 millimeters times 8 millimeters to find the area. What's 8 times 8?
64.
64. Okay? So when you're finding the area of something, convert the side lengths first, then do the multiplication. Did everybody hear that? Make sense?
Okay.
So find the side length, millimeter length, first.
Yep.
All right, so now the last thing is compare the side lengths of the scale drawing with the actual side lengths of the computer chip, aka find the scale factor. So how many millimeters are in a centimeter?
10.
Okay, so I would do 10 times 2.
20.
So my new scale factor would be 10 to 2. Oh, they changed it to centimeters.
What?
Why would you change it to centimeters? I would have changed it to millimeters. Because they wanted to compare. Whatever. So they changed the millimeters to centimeters. I mean the centimeters to millimeters. So they did times 10 on top. So this would become 10 over 2, which when you reduce that becomes 5 over 1, right? All that is telling you is the side lengths of the drawing here you see is 5 times as large as the actual size of the computer chip.
Whoa.
So if you had done the other way, which was converting the millimeters to centimeters, then you would have said the computer chip is 1/5 the size of the drawing.
Whoa.
Make sense?
Yes, ma'am.
You're not just saying yes. You actually understood what I said, yes.
Yes.
Okay, good. All right, so make sure you guys finish all the way through number 8 on the self-assessment by tomorrow. Okay?
Okay. Yes, ma'am.
All right.